Hello, this is Dario Martinez, and this is my lab report for Lab 1, Constant Velocity for Physics 2211. So as an introduction of what be talking about today, I'll talk about an introduction to the lab, so the procedure that I followed, the data that I gathered, and how I plotted that data using Tracker, the model simulation I used to plot the data, and then comparing the observations versus the model, and then analyzing how my results can be improved, and what exactly my data means. So as a small introduction to the lab, for this lab we looked at motion with constant velocity and then analyzed position versus time data. In accordance with Newton's second law and the momentum principle, an object with constant velocity will have zero net force and therefore zero acceleration. So since this motion plotted had no net force, so there was no need for the velocity update formula because the velocity would be constant. However, we would need to use the position update formula, since position would obviously be changing as the object moved, which is the final position is equal to the initial position plus velocity times delta t. So we will plot the data of the observed motion and compare it to a model of the data generated from the observation's initial conditions, and then compare the two and analyze what reasons there be for any differences between the two. So the procedure that I followed for the lab is I recorded a video with a still camera of an object traveling in constant velocity. I recorded a video of a roll of duct tape rolling across a kitchen counter. Then I analyzed the motion of the object with Tracker in order to plot position versus time data. And then using the initial conditions generated from Tracker, I created a computer model of the motion with VPython. And then I compared the data produced from Tracker of the real observations versus the data generated from the model. Here's my observed data. So on the right we can see all my data points with time and position. So at time t equals 0, the object's position was negative 2.126 times 10 to the negative 3 meters, and then after the first time interval at time t equals 0.035 seconds, the object position increased to 0.0138 meters, and we can see that this caused an initial velocity of 0.4559 meters per second, and throughout the entire motion of the object, the entire duration was 1.002 seconds. And this is a picture of my graph from generated using Tracker of the object's position through time. We could see it's a linearly increasing graph with constant velocity. The velocity will be the slope of the graph. And here is the code and the graph generated from the computer model that was created using the initial conditions from the observed data. We could see the object's initial position, its initial velocity, its delta t, and then the loop generated, the loop used to generate the object's position iteratively. We could see the graph of the position is a linear line similar to the previous graph of the actual observations. So when we compare the graphs of the observations versus the model, and the position versus time graphs of my observations and of the computational model created on GlowScript started off very similar because the model used the observations initial conditions, but as time went on we could see that there was a change in the two. So this can be maybe because the model used initial velocity to predict the entire motion of the object, whereas the observations use the actual velocity, not just the initial velocity, to change its motion. And we can see that the model is fully linear, whereas there are some fluctuations in the observed data, probably due to changes in velocity caused by the force of friction with the actual observations, which were not reflected in the model because the model used a net force of 0. And so looking back at the lab, how can the results be improved? So the initial velocity recorded was very fast in the first few frames, and the object was still, due to the fact that the object was speeding up slightly from the initial push, and better data would have been gathered if the analyzed time frame would have been constrained a little further to capture a scenario that better reflected constant velocity. So we can see how the initial velocity of the observed data was 0.455 meters per second, whereas the average velocity of the entire motion was 0.404 meters per second. So clearly the object started off a little too fast. So as can be seen from the initial velocity compared to the average velocity, the object was still speeding up in the first few time frames. Because of this, and that in reality friction is slowing down the object as time proceeds, which was not reflected in the model over projected the position of the object. So what if? So when plotting the data of my observations, I made the arbitrary decision to plot the object's motion along the positive x-axis, and because of that, we had a positive velocity and an increasing slope for the position versus time graph. And this was an absolutely arbitrary decision, and the motion of the object could have been plotted against any axis. Had the movement of the object been plotted along the negative x-axis, the graph would have had a negative slope, as velocity would have been in the negative direction. It would resemble a graph like the one shown in the bottom right corner of the screen, but the data would have essentially conveyed the same information, even though the graph would have been with a negative slope instead of a positive slope. So what does this all mean? The model's net force was set to 0, but that is not truly possible in the real world. A major cause of discrepancy between the observed data and the model are due to the small force of friction felt by the object that is not reflected in the model. Because again, the model had in the simulation the net force was set to zero. And even though we can predict the motion with net force equal to zero, it is not possible to determine the pushes and pulls that cause this. And most likely, though, the forces involved in this motion are the initial push in the positive direction and the force of friction in the opposite direction, which canceled out and to create a net force of zero, which would explains the constant velocity that we saw.